Hey, bio support team. This is Tim Brennan, hoping to share with you some thoughts about a recent lab that we did in class and a summative lab report that students are writing. Um, I want to describe what the lab was about and then show you the resources on the Google Classroom and tell you the kinds of things we've been doing in class to kind of scaffold success for students, okay? So it starts here with this description of some things that we mixed together in a lab, okay? We've been thinking about enzymes and how they interact with things called substrates. And the general idea is that enzymes and substrates kind of match one another, kind of shape-wise. They kind of fit one another like a lock and key. And so catalase is an enzyme that breaks apart hydrogen peroxide. And this is really an important thing for cells because if you build up too much hydrogen peroxide, cells will die. And so this is a simple experiment we can do because yeast is a cell that has catalase in it. And it's easy to make yeast solutions and mix that with hydrogen peroxide. Now, what we wind up doing in order to sort of capture the data, if you will, is we add a little bit of soap to the hydrogen peroxide. And then when the enzyme breaks the hydrogen peroxide up into water and oxygen, the oxygen gets trapped by the soap. And we have this foam column that rises in a beaker, and we time how long it takes the foam to get to a certain point as a way to measure how fast the reaction took place, okay? We would then capture that information here because we are going to sabotage the catalase by adding drops of vinegar. So maybe 0 in the first trial, and then maybe 3 drops in the second trial and 6 drops in the third trial and so forth. And our thinking is if we add vinegar, which is an acid, the vinegar will attack the enzymes, compromising their ability to process the hydrogen peroxide and making it longer and longer to get to that 40 milliliters. Okay, so that was the test, right? If we add acid to the vinegar, can we see the impact that acid will have on the enzyme? And if the enzyme is affected, we call it denatured. It literally winds up becoming a different shape, and it no longer matches that substrate. Okay, so that's what we were doing in class, okay? And let me show you the resources that are available on the Google Classroom. Okay, so on the Google Classroom, there are 3 documents in this Catalase investigation summative, all right? One of them is the summative. One of them is a spreadsheet that is all of the students' data from all sections, okay? I'll show you that in a second. And then another one, you see it says Catalase investigation revisited, okay? As the lab played out, I realized that there was a really specific end game that I wanted students to be able to talk about, and I kind of recast the summative with a slightly different purpose at the end, okay? So let me show you those things one at a time. Here's the investigation summative, the original document, okay? It's a summative. It's a claim based on evidence and reasoning, but I want students to write about this via very particular sections. So there's section 1, the introduction, and these first couple of sentences will be helpful in terms of helping students make that work. If you get them to generally talk about enzymes and substrates and how those things work together as a nice introduction to somebody who hasn't been in class, so they understand the rest of the lab report, that would be a great piece, okay? Then the second section is a prediction. Before the lab happened, we had some expectations about how it was going to play out, and I'll show you more about that in a second. But we generally expected that if there was more acid, there would be more denaturing of enzymes, and it would just take a longer and longer time for the reaction to play out. Then there's an experimental setup, so describing how you actually did the lab, results, and then at the back end discussion, so what does all this mean, right? So what does all this, what does all this mean is sort of what's happening here. And that's where I kind of changed some thinking about the prompt, okay? So all of this is the same, like 1 through 5 is the same, and it's just a recipe, if you will. Do this, do this, do this, do this, okay? Also included is the rubric for developing a claim based on evidence and reasoning. And then here's the original set of distinguished options, and this is the only thing that changes when we go to the other document, okay? Here's the other document, the investigation summative revisited, okay? Students only have a view-only copy of this. They can't write in it, but everything's the same, exactly the same until the very end. I changed our distinguished option. In class, we've been thinking a lot about what we call a mental model of enzymes and substrates, literally drawing them out like cartoons, showing how they match one another and how enzymes break apart substrates and work until the enzymes themselves get denatured, okay? So that's the only difference here, is just like getting them to lock into discussing or showing their mental model, okay? Let me show you the results. Okay, on the left-hand side is all of the data from all of the sections, 0 drops of vinegar, and then 3 drops of vinegar. There's some random things in there, 4, 6 drops of vinegar. We tried to go in steps of 3, 9 drops of vinegar, and then finally 12 drops of vinegar, okay? The times are pretty erratic. I'll show you a graph in a second, but I went ahead and I made average values for the various numbers of drops. So all the 0 drop tests, no acid, had an average time of 79.7 seconds, and then it increased and increased to a point, okay? Let me show you what the entire set of data looks like. It is a mess. Here's all the data points for 0 drops, and then there was a random 2-drop test. All the data points for 3, all the data points for 6. Not a very impressive, data set across 4 sections of sophomores, and a process that was somewhat limited in terms of like the controls that were put in. But nevertheless, we have a general upward trend which supports our thinking, okay? Students were allowed time in class to make this graph and make a graph also of the averaged data. So we took time in class to make these graphs, and those graphs should wind up in their writing as part of the results conversation, okay? I should also say that the first couple of sections, the introduction and prediction paragraphs, we took time in class to write those as well, but some of the students you may be supporting may not have taken advantage of that time. I'll just leave that said without much comment, okay? So they may be starting at number 1 or they may be starting at number 3, but there were times set aside for both writing the first 2 paragraphs and creating the graphs that would help the results section. Okay, let me just, hang on. Sorry, my frame kind of moved on me here. Let me just talk about like the big question that students are trying to answer at the end of this whole thing. If we take a look at the averaged data, okay, you may have noticed this, but the red dots represent essentially what happened. There was an increase in the time from 0 to 3 to 6 drops of vinegar. And then for whatever reason, we didn't really get much of a change in time after that. From 6 to 9 to 12, the data seemed to flatten out unexpectedly, okay? The black dots represent our expectation. This is what we expected to happen. With more vinegar, more acid, more enzymes that are denatured, and fewer that are left in shape in order to break apart the hydrogen peroxide and drive that foam column up. So we expected the black dots to happen, and our mental model led us to believe that that would be true, okay? Of how our mental model of how enzymes and substrates work together. Um, that's how we got to that expectation, okay? So the question that students are wrestling with is, what happened? What do we think went on to explain why the data played out this way, okay? So we want to use our mental model to demonstrate the reasonableness of some of our data, 0 through 6 dots, right? And to show how our mental model cannot explain 6 through 12 dots, all right? And then, and this is the big thinking, right? Can we provide a very specific possible mechanism, either about the molecules itself? Does our mental model need to change, or about the experiment? Did we do something? Was there some lack of control in the experiment that led to, problems with larger sets, larger drops, a larger amount of drops? Now, one more thing you should know is that we spent one whole class period brainstorming ideas and testing out ideas to sort of see if there were one or more or several different possible explanations for this discrepancy. And students walked away with a table of those results, those possibilities. So I want you to know we've been scaffolding this virtually every day for the last week and a half that we've been together. Okay, we've did the experiment. We looked at the results together. We made graphs together. We wrote paragraphs together. We developed possible ideas about what went wrong together. And so I do want to say, if your students don't have much to say about this, if our students are struggling with that, that's a really good sign that they have been disconnected. And I'm sorry to say that so frankly, but like the scaffolding in class has been in place for days. Okay, so I know you're going to do your best to help our students move forward. I know that this is going to be a little bit of a tooth pull in some ways, but please understand that day after day, we have been focusing our efforts on being successful at writing this up, okay? Please reach out to me if you have questions. I'm happy to talk to you about it. I know there's a lot going on with this, experiment, and I can't expect you, not having been here, to get a full view of this. But you should know all of our students have had lots of opportunity to think about this. Okay. Thank you for helping out, and please let me know how I can help you.